Hey, Algebra 2, this is Unit 3, Lesson 4. I'm going to switch it around. Today we started talking about rational exponents and really in Lesson 3 we learned that having a fraction as a power is the same thing as having a root eh, eh, of that same base. And so if you had something raised to the 1/2 power, then that's like a square root of that number. If you had something raised to the 1/3, then that's the same as the cube root of that thing. And yeah, so today we ended up just continuing to work with that, but also involving some power rules. Meaning if you had a power that was a fraction and then that was also then raised to another fraction, how you could multiply those. And really like this is where some simplifying tricks come into play. Yeah, so let's dive in. Okay, so let's see. Yeah, just reviewing class, there were some problems that we had seen like this, like where we had 5 to the 1/3 power raised to the second power, and you could flip those powers, flip them, and you get the same result because what's a third times 2? Well, that's 2/3. That's 2/3. So you would get this 5 to the 2/3 power. Now, what does that mean? Well, the numerator of the fraction still acts as like a power of the 5. So, but the 3 then means that's the root part of it. That's the index number. That's the what number is in front of the radical symbol. And so 5 to the 2/3 power is the same as that 3 becomes the cube root, and the 2 is a power that either goes with the whole thing with parentheses on the outside, or it goes with the 5 itself, the base itself. And so yeah, you could express it like this, or you could express it like this. The nice thing about this version is that since we can't take the cube root of 5, what we can do is we can square 5 and simplify it one step further. So the fully simplified version is the cube root of 25 when you do 5 times 5 squared. And then it says write 5 to the 4/3 power. Well, okay, well, the 3 is still meaning the cube root, and the 4th power means you're going to raise 5 to the 4th power. And so that would be 5 times 5 times 5 times 5. That would be 625. We see this. Either of these answers are correct. Okay, anyway, that was class. Class was the idea of, working with some of these. Now, we didn't graph these, but we did take these powers that were here and estimate them using, using perfect squares that we already know. All right, let's get to the homework. So homework was 1 through 3 and number 6. So let's see, number 1. Why is the answer 32? So it says evaluate 8 to the 5/3 power. Well, okay, we got a couple ways that we can do this. The 3, remember, means we're going to take the cube root of 8, and the 5 means we're going to raise it to the 5th power. So we can either raise 8 to the 5th power now, or we can take the answer after we find the cube root of 8 and then raise that to the 5th power. And that's what we're going to do because, well, what is the cube root of 8? What, if we put a little radical symbol here for the 8, what times what times what? 3 times equals 8, and that would be 2. Then we would have 2 being raised to the 5th power. So that answer, and 2 to the 5th power is 32. Select all the expressions that are equivalent to 64 to the 3/2 power. Okay, so look at that. 64. If we were to take that, the 2 here means that we would take the square root of 64, and we ask ourselves, what times what is 64? And yeah, that would be 8. So 8 times 8 is 64. And so we could have 8 to the 3rd power, which we have here. And let's see what happens when we multiply that out. 8 times 8 times 8 is 512. So B is a solution and C is a solution. If we continue working with this, is 96 equal to 512? No, so A can't be an answer. 4 squared. 4 times 4 would be 16. Is that equal to 512? No. So if we're looking for all the ones that are equivalent to it, they're all going to have answers that are equal to 512. Let's see, the square root of 64 to the third power. Now that is equivalent to this, because that's literally what this is saying to do with it. And the cube root of 64 to the second, no. Remember, the 3 that's up here acts as a power, either to the 64 or to the whole thing afterwards. And the 2 is the index number that goes outside of the root. And so yeah, not a 3. Okay, so yeah, it is B, C, and E. Number 3, I asked you to do, write the expression of 17 to the 4/3 power using radicals. Now, they're not saying to evaluate it because it's going to be an ugly number. So they're just saying to write the expression. So since it has that 3 there, that 3 hops out front and becomes a cube root, and the 4 becomes a power. Again, either to the whole thing or to just the base inside. So then I skipped the rest of these and I said, hey, do number 6. And that it's just like what we've been doing, except this one's easier. All right, since we got a 1 up top, that power of 1 means we can just kind of ignore it, and because anything to the first power is just 1, and this 2 here means that we'll want the square root of 2, the square root of 23, and so D would be our answer. All right, so yeah, hoping that made sense. Yeah, the next lesson we jump into seeing more expressions with negatives, negative fraction powers. There's a lot of rules. So I hope you're taking notes. I hope you're kind of banking some of your understandings either in the packets or on the homework or in your notebook. This is a unit that's got like a lot of little details. And a lot of vocabulary that goes along with it. So do yourself a favor and start to create like your own little study guides, your study materials. Take care.